heights and distance. In this module, we will learn about applications of trigonometry. Today we will be studying about some ways in which trigonometry is used in the life around us. The knowledge of trigonometry is used in astronomy to construct maps, determine the position of an island in relation to the longitudes and latitudes, etc. We will see how trigonometry is used for finding the heights and distances of various objects without actually measuring them. Arun went to see a TV tower. Standing on the ground in front of tower, he was trying to look at the top of the tower. Let us draw a line from the eye of Arun to the top of the tower. We name it as AC. The line AC is called the line of sight. Let us draw another line from the eye of Arun to tower parallel to ground and name it as AB. The angle BAC, so formed by the line of sight with the horizontal, is called the angle of elevation of the top of the tower from the eye of the student. Thus, the line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of elevation of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. We make this angle of elevation many a times as when we watch a plane or a bird flying in the sky. When we fly a kite, when we talk to someone who is standing on a height from us. Similarly, there is another angle called as angle of depression. This angle is formed when we see from a height downwards. The angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. Look at this example. The girl sitting on the balcony is looking down at a flower pot. In this case, the line of sight is below the horizontal level. The angle so formed by the line of sight with the horizontal is called the angle of depression. Let us again look at the figure showing angle of elevation. If we want to find the height CD of the tower without actually measuring it, what information do we need? We would need to know the following. 1. The distance DE at which the student is standing from the foot of the tower. 2. The angle of elevation, angle BAC, of the top of the tower. 3. The height AE of the student. With the help of this information and using trigonometry, we can find the height of tower without measuring it. Let us see this through some examples. Heights and distance. Part 2. A tower stands vertically on the ground. From a point on the ground, which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. Solution. First, let us draw a simple diagram to represent the problem. Here, AB represents the tower, CB is the distance of the point from the tower, and angle ACB is the angle of elevation. We need to determine the height of the tower, that is AB. Also, ACB is a triangle right-angled at B. To solve the problem, we choose the trigonometric ratio tan 60 degrees as the ratio involves AB and BC. Now, tan 60 degrees is equal to AB upon BC. That is, root 3 is equal to AB upon 15 as value of tan 60 is root 3. That is, AB is equal to 15 root 3 meters. Hence, the height of tower is 15 root 3 meters. Next example. The angles of depression of the top and the bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 45 degrees respectively. Find the height of the multi-storied building and the distance between the two buildings. Solution. BC denotes the multi-storied building and AB denotes the 8-meter tall building. We are interested to determine the height of the multi-storied building, that is BC, and the distance between the two buildings, that is AC. Look at the figure carefully. Observe that PB is a transversal to the parallel lines PQ and BD. Therefore, angle QPB and angle PBD are alternate angles and so are equal. So, angle PBD is equal to 30 degrees. Similarly, angle PAC is equal to 45 degrees. In right triangle PBD, we have PD upon BD is equal to tan 30 degrees is equal to 1 upon root 3, or BD is equal to PD root 3. In right triangle PAC, we have PC upon AC is equal to tan 45 degrees is equal to 1. That is, PC is equal to AC. Also, PC is equal to PD plus DC. Therefore, PD plus DC is equal to AC. Since AC is equal to BD and DC is equal to AB is equal to 8 meters, we get PD plus 8 is equal to BD is equal to PD root 3 . This gives PD is equal to 8 upon root 3 minus 1 meters, which gives 8 into root 3 plus 1 upon root 3 plus 1 into root 3 minus 1 meters is equal to 4 into root 3 plus 1 meter. So the height of the multi-storied building is 4 into root 3 plus 1 plus 8 equals to 4 into 3 plus root 3 meters, and the distance between the two buildings is also 4 into 3 plus root 3 meter.
Heights and distances. A kite flying at a height of 75 meters from the level ground is attached to a straight string inclined at 60 degrees to the horizontal ground. Find the length of the string to the nearest meter. Let's solve this. Let K be the kite and AK be the string. Then the height of the kite is equal to KB is equal to 75 meter. In the right angle triangle KBA, KB by AK is equal to sine 60 degrees, which is equal to root 3 by 2. This implies AK is equal to 2 into KB by root 3 is equal to 2 into 75 by root 3 meters. Therefore, AK is equal to 50 into 3 by root 3 meters is equal to 50 root 3 meters, which is equal to 50 into 1.73 meters is equal to 86.6 meters is equal to 87 meters approximately. Let's take the next example. A vertical tower is 20 meter high. A man standing at some distance from the tower knows that the cosine of the angle of elevation of the top of the tower from that place is 0.53. How far is he standing from the foot of the tower? Let's solve this. Let AB be the tower and man is at C. Let angle ACB is equal to theta, where BC is horizontal. Let BC is equal to 8 meters. From the question, cos theta is equal to 0.53. In the right angle triangle ABC, tan theta is equal to AB by BC is equal to 20 by A. This implies A is equal to 20 by tan theta is equal to 20 by sin theta upon cos theta is equal to 20 cos theta by sin theta. Therefore, A is equal to 20 into 0.53 divided by, for sin theta we can write under root 1 minus cos square theta is equal to 10.6 divided by under root 1 minus 0.53 whole square is equal to 10.6 divided by root of 1 minus 0.28 is equal to 10.6 divided by root of 0.72 is equal to 10.6 divided by 0.85 is equal to 12.47 approximately. Therefore, required distance is equal to 12.47 meter approximately is equal to 12.5 meters approximately. Let's take the next example. From a board 300 meter away from a vertical cliff, the angle of elevation of the top and the foot of a vertical concrete pillar at the edge of the cliff are 55 degrees 40 minutes and 54 degrees 20 minutes respectively. Find the height of the pillar correct to the nearest meter. Let's solve this. Let the vertical cliff be AB and the pillar be BC and the board be at P. The angle of elevation of C and B are angle CPA equal to 55 degrees 40 minutes and angle BPA is equal to 54 degrees 20 minutes respectively. Also, PA is equal to 300 meter. In the right angle triangle CPA, AC by PA is equal to tan 55 degrees 40 minutes is equal to 1.4605 plus 36 is equal to 1.4641. Therefore, AC by 300 meters is equal to 1.4641. This implies AC is equal to, on cross multiplication, 300 into 1.4641 meters is equal to 439.23 meters. Also, in the right angle triangle BPA, AB by PA is equal to tan 54 degrees 20 minutes is equal to 1.3916 plus 17 is equal to 1.3933. Therefore, AB by 300 meters is equal to 1.3933. This implies AB is equal to 300 into 1.3933 meters is equal to 417.99 meters. Therefore, BC is equal to AC minus AB is equal to 439.23 minus 417.99 meters is equal to 21 meters approximately. In the given figure, from the top of a building AB 60 meters high, the angle of depression of the top and the bottom of a vertical lamppost CD are observed to be 30 degrees and 60 degrees respectively. Find first the horizontal distance between AB and CD and second the height of the lamppost. Let CE perpendicular AB. By geometry, angle ACE is equal to 30 degrees and angle ADB is equal to 60 degrees. Also, BD is equal to EC is equal to distance between AB and CD CD is equal to EB. Let the height of the lamppost CD is equal to h meters. In the right angle triangle ABD, tan 60 degrees is equal to AB by BD is equal to 60 meters by BD. This implies root 3 is equal to 60 meters by BD, or BD is equal to 60 by root 3 meters is equal to 20 root 3 meters is equal to 20 into 1.732 meters is equal to 34.64 meters. Therefore, the horizontal distance between AB and CD is 34.64 meters. Second, in the right angle triangle AEC, tan 30 degrees is equal to AE by EC is equal to AE by BD is equal to AE by 20 root 3 meters. This implies 1 by root 3 is equal to AE by 20 root 3 meters. Therefore, AE is equal to 20 meters. Therefore, CD is equal to EB is equal to AB minus AE is equal to 60 meters minus 20 meters is equal to 40 meters. Therefore, the height of the lamppost is 40 meters.
So our question number 1 is, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So first let us understand our question from our figure. In this question, circus artist is climbing a rope which is 20 meters long, and this rope is making angle of 30 degrees with the ground, and on this side this rope is tied to a vertical pole. So in this question we have to find the height of this vertical pole. What we have to find is height of pole AB. In right triangle ABC we have sine 30 is equal to, we know formula for sine is opposite side over hypotenuse. If we look in our figure, this is 30 degree, opposite side is AB and hypotenuse is AC. Putting the values here, we know that sine 30 is 1 by 2 AB over AC. From our figure we can see our AC is 20. So from here we have twice AB is equal to 20. This implies AB is equal to 10 meters. Therefore, height of vertical pole is 10 meters. So our question number 2 is, a tree breaks due to storm and the broken part bends so that top of the tree touches the ground, making an angle of 30 degree with it. the distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. So understanding our question from figure, what is happening in this question is that this was a tree. Due to storm, this tree breaks down and the broken part of the tree touches the ground, making an angle of 30 degree. And the distance between the foot of the tree and to the point where the tree touches the ground is 8 meters. We have to find what was the original height of the tree. So this is the height of the remaining part, and this is the height of the part which has broken and now is touching the ground. So the total height in this question, we have to find the height of the tree. So total height of the tree will be AB plus AC. So now solving our question, in right triangle ABC, tan 30 is equal to, we know the formula for tan is opposite side over adjacent side. So from our figure, this is our 30 degree, opposite side is AB and the adjacent side is BC. Putting the values here, we will have tan 30 is 1 by root 3. This is equal to AB, and from our figure BC is 8. So from here AB will be equal to 8 by root 3 meters. Now once again, considering the same triangle, in this triangle sine 30 degree will be equal to, now formula for sine as we know is opposite side over hypotenuse. Looking in our figure, this is our 30 degree, opposite side is of course AB and hypotenuse here is AC. Putting the values, we know value of sine 30 is 1 by 2. This is equal to AB over AC. So AB we have calculated it 8 by root 3. So in place of AB we can write 8 by root 3 divided by AC. So cross multiplying, we'll have AC is equal to 16 by root 3. Now height of tree is equal to AB plus AC. AB we have calculated to be 8 by root 3 plus AC is 16 by root 3. Just adding the two, taking LCM, we'll have root 3. This is 24 by root 3. Rationalizing, multiplying numerator and denominator by root 3, we'll have this is 24 root 3 divided by 3. So this will come out to be 8 root 3. Therefore height of tree was 8 root 3 meters. Now our question number 3 is, a contractor plans to install 2 slides for children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas for elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? So in this question, we have to find the length of the slide in each case. Now let us understand our question with the help of our figure. Now looking at our figure, now it is given in the question that a contractor wants to make 2 slides. One slide is for the children below the age of 5 years and the other slide is for the children above the age of 5 years. Now slide ABC is for the children below the age of 5 years. We can see that the height of this slide, that is AB, is 1.5 meters and it is inclined at an angle of 30 degree. And this slide DBE is for elder children. The height of this slide is 3 meters and it is inclined at an angle of 60 degree. In the given question, we have to find the length of slide. That means AC in this case and DE in the case of the slide for elder children. First we will find AC, that means length of the slide for the children below the age of 5 years. Now in right triangle ABC, that means in this triangle, we know this angle which is equal to 30 degree. We know the length of AB which is equal to 1.5 meters, and we have to find AC. So for our angle of 30 degree, AB is the opposite side and AC is the hypotenuse. So we will make use of the ratio of sine. Now sine 30 degree will be equal to opposite side over hypotenuse, and for angle of 30 degree, the opposite side is AB and the hypotenuse is AC. So sine 30 degree is equal to AB over AC. Now this will imply, we know that sine 30 degree is equal to 1 by 2, and putting the values of AB and AC. Now AB is 1.5 meters and we'll write AC as it is. So writing the values here, in place of AB we can write 1.5, and in place of AC we'll write AC only. Now this will imply, here we will cross multiply, and on cross multiplication we will have AC is equal to 1.5 into 2, which is equal to 3 meters. Now we will find the length of the slide DE. This is the slide for elder children. Now similarly, in right triangle DEB, our sine 60 will be equal to opposite side over hypotenuse, and for this angle of 60 degree, the opposite side is DB and the hypotenuse is DE, and we can see here that DB is equal to 3 meters. So our sine 60 degree will be equal to DB over DE. Putting the values here, we will have, this implies, we know that sine 60 degree is equal to root 3 by 2. So this will be equal to, in place of DB, we can write 3 divided by taking DE as it is. Now this will imply, on cross multiplication, we will have root 3 into DE is equal to 6. So this will imply from here, our DE will be equal to 6 by root 3 meters. Now we will rationalize the denominator, and for rationalizing the denominator, we will multiply the numerator and denominator by root 3. So this will imply from here, DE will become equal to 6 by root 3 into root 3 and into root 3 in the denominator also. So this will imply here, our DE will come out to be equal to 6 root 3 by 3 meters, which is equal to, now 3 can cancel with 6, this will become 2 root 3 meters. Therefore, lengths of the slides are 3 meter and 2 root 3 meters. This is our answer. Now our question number 4 is, the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So in this question, we have to find the height of the tower. So first let us understand our question with the help of our figure. Now it is given in the question that we have a tower. Let us suppose that AB is a tower, and at a point C, which is at a distance of 30 meters from the foot of the tower, the angle of elevation of the top of the tower is 30 degree. From this information, we have to calculate the height of the tower AB. So to solve the question, let the height of tower AB be equal to h. So writing h here. Now for this 30 degree angle, we have to find h, that is our opposite side, and we are given BC, which is our adjacent side. So we will make use of tan, because tan 30 degree will be equal to opposite side over adjacent side. Now in right triangle ABC, tan 30 degree will be equal to opposite side over adjacent side, and we can see that opposite side is AB and the adjacent side is BC. So tan 30 degree is AB over BC. Now this will imply, we know that tan 30 degree is equal to 1 by root 3 is equal to, in place of AB we can write H here, divided by BC is given to be 30. Now this will imply, from cross multiplication we will have H is equal to 30 by root 3 meters. Now we will rationalize the denominator here. That means we'll multiply the numerator and denominator by root 3. So this will imply, from here our H will be equal to 30 root 3 divided by root 3 into root 3 meters. Now this implies, from here our H is equal to 30 root 3 divided by 3 meters. This 3 will cancel with 30. Here we'll have 10. So this will imply from here that our H is equal to 10 root 3 meters. Therefore, height of the tower is 10 root 3 meters. This is our answer. Question number 5 is, a kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. So in this question we have to find the length of the string. So now let us understand our question from the diagram. A kite is being flown here, and the kite is flying at a height of 60 meters above the ground. And this is the string which is being used to fly the kite. The string is being tied to the ground, and the angle which the string is making with the ground is 60 degrees. In this question we have to find the length of this string. So this is our angle, which is 60 degrees. AK is given to be 60 meters, and we have to find this length. So in this question we'll make use of sine theta. Why? Because relation of sine is opposite side over hypotenuse. Let the length of string OK is equal to L. So we'll suppose that this length is L. In right triangle KAO, sine 60 is equal to, we know the formula for sine is opposite side over hypotenuse. From our figure, this is our angle 60 degree. Opposite side here is KA and the hypotenuse is KO. So opposite side is KA divided by KO. Now we know that sine 60 is equal to root 3 by 2. This is equal to KA from our figure is 60 divided by KO is L. Cross multiplying we'll get root 3L is equal to 2 into 60. That means L is equal to 120 divided by root 3. Multiplying the numerator and denominator by root 3, we'll have length is equal to 120 root 3 by 3. This can get cancelled. This will be 40 root 3. So L is equal to 40 root 3 meters. Now our question number 6 is, a 1.5 meter boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 45 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building. So first let us understand the question with the help of our figure. Now here in this question we have a building AC which is 30 meters high. We have a boy which is being represented by GF, who is 1.5 meters tall. This boy, from his position, observes that the angle of elevation of the top of the building is 30 degrees. Then the boy walks some distance and reaches position ED, and from this position he observes that the angle of elevation of the top of the building is 60 degrees. From this data, we have to calculate the distance moved by the boy towards the building. That means we have to calculate GE. So this is what we have to find in this question: distance walked by the boy towards the building, GE. Now to solve the question, let GE be equal to X. That means our this length is X. And here we can see that GEDF, this is a rectangle. So this length will also be X, and this length ED will be equal to 1.5 meters, being equal to GF. Similarly, if ED is 1.5 meters, then BC will also be 1.5 meters. Now if BC is 1.5 meters and we are given in the question that the complete length AC is 30 meters, from here we can calculate AB. This will be equal to 30 meters minus 1.5 meters, which will be equal to 28.5 meters. Now in right triangle ABE, that means in this triangle tan 60 degree will be equal to opposite side AB over adjacent side BE. So this implies that tan 60 degree is equal to AB over BE. Now this will imply, putting the values here, we know that tan 60 degree is equal to root 3. This will be equal to AB. In place of AB, we can write 28.5 divided by BE as it is. This will imply from here, by cross multiplication, we will get BE is equal to 28.5 divided by root 3 meters. This we can call as our first. Now in right triangle ABG, that means this triangle tan 30 degree will be equal to opposite side AB over adjacent side BG. This implies tan 30 degree is equal to AB over BG. Now this will imply, we know that tan 30 degree is 1 by root 3. This will be equal to, in place of AB, we can write 28.5 from our figure. We can see that AB is 28.5 divided by BG. BG, we can see that this is equal to GE plus EB. So we can write here GE plus EB. Now this will imply 1 by root 3 is equal to 28.5 over GE plus EB. Putting the values here, we can see that GE is equal to X, and in place of EB, from our first, BE is equal to 28.5 by root 3 meters. So putting it here in place of EB, we can write this value. So we'll write here 28.5 divided by root 3. Now this will imply, from cross multiplication here, we will have X plus 28.5 divided by root 3 is equal to 28.5 into root 3. This will imply from here our X will be equal to 28.5 root 3 minus 28.5 divided by root 3, and the units will be meters. Now this will imply from here X will be equal to, from these two terms we can take 28.5 common. So taking 28.5 common, inside the bracket we'll be left with root 3 minus 1 by root 3 meters. This will be equal to 28.5. Keeping it out, inside the bracket we will take root 3 as our LCM. So this will become root 3 into root 3 is 3 minus 1 meters.
So from here, our x will be equal to 28.5 into 3 minus 1 is 2 by root 3 meters. Now this implies from here our x is equal to 28.5 into 2 by root 3. On rationalizing the denominator, we'll have into root 3 here and into root 3 in the denominator. Units will be meters. So here our x will be equal to 28.5 into 2 root 3 divided by root 3 into root 3 is 3 meters. Now here this 3 can get cancelled with 28.5. This will come out to be 9.5. Now from here this will imply that our x is equal to 9.5 into 2 is 19.0. So this will become 19.0 into root 3 meters. Therefore, distance walked by the boy towards the building is 19 root 3 meters. This distance GE is the distance which is coming out to be 19 root 3 meters. This is our answer. Now our question number 7 is, from a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45° and 60° respectively. Find the height of the tower. So in this question, what we have to find is, we have to find the height of the tower H. Now first, let us understand our question with the help of our figure. In this question, we are given a building BC which is 20 meters high. On the top of the building BC, a transmission tower is fixed AB. Now first, let us understand the question with the help of our figure. In this question, we are given a building BC which is 20 meters high. On the top of this building, we have a transmission tower AB. This is our transmission tower. From a point D on the ground, the angle of elevation of the bottom of the transmission tower is 45°, and the angle of elevation of the top of the transmission tower is 60°. From this information, we have to calculate the height of this transmission tower AB. Let it be equal to H. So we will find H in this question. So now to solve the question, let AB be equal to H and let DC be equal to X. Now in right triangle BCD, that means in this triangle, tan 45° will be equal to opposite side BC over adjacent side CD. So this implies that tan 45 is equal to BC over CD. Now this will imply, putting the values here, we know that tan 45° is equal to 1. In place of BC here, we can write 20 divided by CD. We have supposed it to be equal to X. So from here, this will imply that our X will come out to be equal to 20 meters. So we can write here X is equal to 20 meters. Now in right triangle ACD, that means in this triangle, tan of 60° will be equal to opposite side AC over adjacent side CD. So this implies that tan 60° is equal to AC over CD. Now this implies, putting the values here, tan 60° is equal to root 3 is equal to AC by CD. For AC, we can write here, this is our AC, we can write H plus 20 divided by CD. This is our CD, and we have calculated CD as X is equal to 20 meters. So writing 20 here. Now this will imply, on cross multiplication, we will have 20 root 3 is equal to H plus 20 This implies from here our h will come out to be 20 root 3 minus 20 meters. So this will imply from here that our h is equal to, from these two terms we can take 20 common. Taking 20 common, inside we'll be left with root 3 minus 1 meters. So this is what we had to find in this question. Therefore, height of the transmission tower is 20 root 3 minus 1 meters. This is our answer.